Well, up till now, we haven't worried about an ion having multiple charges. We looked at the column number. Sodium ion, that was 1A, so it has a plus charge on it. Magnesium ion, it's from 2A, it has a 2 plus charge on it. And there was no doubt, we used the periodic table to guide us on that. But I've avoided the transition metal area, and I've also avoided tin and lead because they present problems. Here's a transition metal, iron, and it will actually form two different ion charges. You have an Fe2 plus and Fe3 plus. Well, so you just can't call it iron because you don't know what the charge is anymore. It's ambiguous. Therefore, an old naming system was to go back to the Latin root of the element, and then you put an OUS or an IC ending on it, depending upon the charge. Well, let's see if we can pattern match. Ferrous and stannous ions both have a 2 plus charge. Well, surely that means since ferric ion has a 3 plus, then stannic ion must have a... No, it has a 4 plus charge. All the us in the ic means is that the us version has a lower charge than the ic. So ferrous, 2 plus, which is lower than ferric, which is 3 plus. And the same thing with stannous and stannic. Okay, so that doesn't really help. I mean, it helps a bunch of chemists and scientists, but it doesn't help people to learn chemistry. It still makes the rules difficult to learn because there's a lot of memorization. So we came up with a different set of rules. This system was developed in the early 1900s by a German chemist named Alfred Stock, and you use Roman numerals to state the charge. Now, this is not going to be a retroactive system to everything we've done so far. The sodium ion is still the sodium ion. We're not going to add these stock numbers to it. We're only going to use it in cases in which the charge is unknown and in which there are multiple charges possible. So instead of ferrous and ferric, we call them the iron 2 and the iron 3 ions. Similar for SN2 plus and SN4 plus. Now, when do you use this stock system? We haven't used it so far, right? So this is the rule that I go with for my classes. When you know you have an ionic compound, you look at the metal, and only the metal, and you ask yourself, where is this element located? If it's a transition metal, or if it's tin, or if it's lead, then you will use a stock number on it. With these three exceptions, these seem to be the pretty common exceptions across textbooks. The silver ion has a positive charge on it, so we're not going to worry about a silver 3 ion. Cadmium and zinc ions both are commonly found with a 2 plus charge on them. So you have to commit these three to memory. Now, there are some differences across books and across instructors, so you need to make sure and follow the rules as laid down by your instructor. And the reason why there are some differences, the official IUPAC recommendation is actually vague. It says that the stock numbers do not have to be used, which suggests they can be used. So what we're doing is we're using general practice over the years. So no stock numbers on the metals that we've talked about so far in columns 1A, 2A, or 3A. Only transition metals, tin, and lead, and these three exceptions do not get stock numbers. And if you look around, you'll find that there are other exceptions in the transition metal area. that don't use stock numbers. So this is the guideline I use for my students. Any other exceptions that you find, I will not ask you about. I have to keep the list down to something that's manageable and what I believe is common. Well, the only way to get a handle on this is to do some examples. And we're writing the formula from the name. So that makes it nice if you get a stock number, because you know what the charge is. You know it's going to be a cation, and the Roman numeral tells you the charge. So mercury 2 has a 2 plus charge. And chloride has a minus because it's 7A. And now you do what we did before. You do the charge balancing. Now, if you don't get the charge balancing, then you need to go back, watch a previous podcast, and do some work to understand the charge balancing, because I'm going to assume now that you know how to charge balance. Chromium 3 oxide. You know the charge on the chromium ion. You know the charge on the oxide because it's from 6A. Least common multiple of 2 and 3 is 6. Therefore, there's the chemical formula for chromium 3 oxide. Silver nitride. There you go, silver. Okay, no stock number. All right, let me see. You go and find it. It's in the transition metal area. You think, oh, wait a minute, I can't figure out the charge. You have to memorize it. Just commit it to memory. There is a reason why the silver ion has a positive charge, but I'm not going to address it here. Right now, we're just taking it as something to memorize. Least common multiple of 1 and 3 is 3. Therefore, there's the chemical formula for silver nitride. You know the charge on the lead ion because of the Roman numeral. The least common multiple of 4 and 2 is 4. Therefore, there's the chemical formula for lead 4 sulfide. Zinc is one that you have to memorize. It is 2 plus. Oxide because it's 6A. 2 plus, 2 minus, the charge is balance, ZNO. And then mercury 1 bromide. Okay, I lied earlier. There's an additional one you have to memorize. Because unless you've read about this, you'll write mercury 1 ion wrong. That is the chemical formula for the mercury 1 ion. My understanding of this is the mercury 1 compounds are unstable, and so they tend to decompose, and when they decompose, they form a mercury atom and then a mercury 2 ion. So they write the mercury 1 like this. So, bottom line, commit it to memory. Least common multiple of 2 and 1 is 2, so you take the Hg2, but then you need 2 bromides to balance it out. Now we've had more and more and more rules. They're starting to layer on each other, and they may very well be mixing around with each other, so you need to go and practice. Go to my website, use the inorganic nomenclature quizzes, and just start quizzing yourself again and again and again and again. It's the only way to get better at this.